Welcome back, ladies and gentlemen. And for the next session, I'm sure none of us would like to be treated by a doctor who does not keep up to date with the phenomenal advances in medical care. In this session, we will see how technology can assist in educating a healthcare provider. And for this, allow me to call on the dais Mr. S.S. Reddy, Director, Medversity, who will chair the session. Ladies and gentlemen, let us give a huge round of applause and welcome him. Welcome, sir. I'd also request the panel of speakers to please come on the dais. May I invite Dr. U.K. Anantha Padmanabhan, the President, Kovial Medical Center and Hospital, Coimbatore. Mr. V. Balasubramaniam, Professor, Department of Anatomy, St. John's Hospital, Bangalore. Dr. Neeraj Raj, Managing Director, Med RC, Hyderabad. Mr. Sid Ahuja, Vice President, JV Alcatel Lubent, Bell Labs Innovations, New Jersey, USA. And Mr. Sanjeev Zucchi, the Chief Executive Officer, Medversity Online Limited. Gentlemen, I request you to please take your seats on the dais. Welcome, sir. And the first speaker of this session is Dr. U.K. Anantha Padmanabhan, the President, Kovial Medical Center and Hospital, Coimbatore, India. I now hand it over to you, sir.
Can you open this? Excuse me. Sure. I would. Your pointer is there. Good afternoon, ladies and gentlemen. Dr. Ganapathy has always made it a point to make me the first speaker and also the maybe the afternoon speaker. And I told him, why are you doing this? And he said, look, Anantha Padmanabhan, maybe we believe that you are a good speaker. But I said, sorry, I don't believe that I am a good speaker, but I think I am going to tell you what I have been doing, and you have to judge whether your speaker is a good speaker and the content is good. And I was very happy to be here last year, and I am privileged to be here this year. What I am going to talk to you today is about the revolutionary concepts in integrating the operation theaters and the intensive care areas using ICT applications. Today, ICT has become the backbone of any hospital setting, and people like us have been very passionate in using this ICT applications, be it in the operation theater or intensive care area, or maybe in the food services or transporting patients, billing, whatever. But I think today's focus is on the recent trends in integrating these very critical areas of the hospital. What I am going to run through very quickly is to tell you about where I am working and what kind of facility in which I am working and where this is being practiced. And it is going to be a sort of a case study. I am sure you will appreciate it. And this is the hospital in which I am working. This is now a 800-bed hospital. It's a core medical center. This is the expansion going on in the hospital, and this will give you an idea how these projects are implemented and how useful are they when you start really using them in a large, maybe high-tech hospital. This is a hospital with 10 lakh square feet spread on a 22-acre plot. And this is the new extension building with 8-feet corridor, and everything is Wi-Fi enabled in the hospital, which is very useful to the doctors. And this is the auditorium facility. You may be wondering why I'm showing this auditorium facility when you're talking about the ICT applications in operation theater and intensive care. I have a purpose for showing this. You will know about it as we go along this presentation. Of course, these equipments are also very useful. I'm not going to go through the biomedical equipments, but these equipments are very, very useful in intensive care and operation theater. And we work, integrated them, and we work very closely with these departments as well. And the cath lab, our ultimate is the linear accelerator, which is about almost 14 crores, which has come into the hospital very recently. So all these equipments, all these facilities make it a high-tech hospital. And you will see that in this presentation, all that I talk will be relevant to this hospital and maybe similar hospitals around the country, which I am sure many of you have been working with such hospitals. And very quickly, I have been here for the last almost 48 hours, and I have heard all the presentations. I thought these are all some of the take-home messages I have, which has a lot of relevance to my presentations too. Every achievement has a beginning. Anything that is not measured cannot be controlled. Very relevant to my presentation. Indian healthcare IT should be inclusive, equitable, and sustainable. That's what they told me. If the solution which I am going to tell you is very expensive, who is going to use it? Indian healthcare has moved from transforming mode to the revolutionary mode. True. Most hospitals are data rich and information poor. Very good, correct? Modernizing and cloud computing has come into vogue. Data mining and clinical analysis has really made a mark in many of the hospitals now. Now, focus is on total solution. When people like us started our career, maybe in Apollo Hospital and then into Core Medical Center, we were using computers in silos, as I was telling you in my while I was chairing the session. But today you are talking about maybe 300 to 400 computers networked all over the hospital with a data center, and I think that transformed the way hospitals are working. So from individual computers to networking to solutions today. As somebody was saying this morning, we are not talking about computers and devices. We are not talking about products. We are talking about computers, devices, technologies, all working together to give you a solution. Okay, what are the technologies we are talking about? There are hundreds of technologies, but I am talking of certain technologies are very relevant to the war integration we are talking about. One is the internet technology, another is the intranet technology, imaging technology, biometrics, mobile technology, barcodes, pneumatics, networking technology, and of course the PRI technology, which is the primary rate interface used in communication. So it's a digital technology. What are the devices which are very relevant to this integration? When you're talking about devices, I would say computers, laptops, and now we are talking about tablet PCs. We have been using computers, we have been using laptops in our hospitals, but when are we going to use iPads? How are we going to use iPads in the hospital? iPads are going to be relevant when we have a Wi-Fi enabled hospital, which we have. But we have some constraints. Maybe when you're talking about iPads, the OS is completely different. We work on a Microsoft OS that work on a Mac OS. Okay, then medical devices and equipment, we are talking about total solutions. Mobile phones communicate critical lab results to my ICU doctor, to my operation theater anesthetist. OT cameras, we actually project what's happening in the operation theater into our auditoriums. Maybe even send it outside the country. Barcode readers, we in fact track the patients who are transported in the hospital. I told you yesterday morning that 500 patients are transported across the hospital, and we use a barcode ID on them, and these barcode IDs are tracked along with the patient attenders who are transporting them. Patient attenders are also given barcode IDs, and we use a tracking system where we know when that request came, when that ward boy or ward girl started transporting the patient, when he arrived at the operation theater, and when he was brought back, all are tracked using the barcode. Believe me, because of that, I have improved the efficiency by almost 40%. And biometric devices, maybe even OT doors in the hospital, the solid doors have the electronics in it. And of course, networking, we are talking about a 1 gigabyte bandwidth in the hospital for using PACS. Very quickly, I am not going to spend much time. But if I don't again talk about electronic medical records, my operation theater integration won't be relevant. So I'm not going to talk about electronic medical records more, but it is sufficient if I say that these kind of electronic medical records also go into the operation theater and into the ICU electronically through the network. This is the screen which we use, and this is the MR patient list, of course. And this is the patient transfer. This is a part of the HIS system, okay, and the PACS is also integrated into this system. Then why are we talking about integrated OR or integrated ICU? As the gentleman who was talking in the morning said, when you record the data through the devices, through the network, using a computer, there is very little variability in the data. If you are talking about the nurse to record the BP, she may record it differently in different times, which may not be so. So the labor productivity also increases, and easy portability of data. I can port it anywhere I want, and the process control is there. When I am able to get the BP values directly from my monitor into my HIS server, I'm able to have a better quality, and I can have even quality gates whenever I want to in the entire process. And more quality time is available to the nurses. Somebody was saying, what is the use of doing IT everywhere? I think there is sense in doing IT everywhere because we want to release the quality time to the nurses and the doctors. Why do you want to do things which doctors and nurses need not do and don't want to do? So I think that way ICT makes a lot of sense to people like us, and we have been greatly benefited. I'm going to quickly show you some of the integrated OR solutions. This is the classical theater we have in the hospital. If you see in this theater, we have a workstation. You will see it here. Can I have the pointer, please? You will see the workstation there. In the workstation, the PACS comes into the workstation. And I can pull up HIS, I can pull up PACS, I can pull up any information. I can pull up anything I want into the workstation. And you find you have LED lights there, you have pendants there. Everything can be controlled through an IT system. But the hospital we have is completely IT enabled, but it is not OR integrated. Please understand, the OR integration is completely different from the facilities we have. All the facilities are available. Maybe you can remotely raise the table height, and you can switch on and switch off the lights. Maybe you can pull up all the details from the HIS server, but it is not happening through an interface. But now what has happened? This is a hospital in Germany. They visited, I spent some time, and this is an integrated OR which we are trying to replicate in the hospital. And you will see a surgeon, an onco surgeon doing a procedure. You will see there is only one nurse, and the others are all their registrars from Russia. And he is doing a 3.5 hour surgery on him, and this OR is completely integrated. There is an interface software. that software controls all the devices, be it a laparoscopy equipment, be it operation theater lights, tables, pendants, maybe your room lighting, video recording, HD recording, everything is controlled through an interface program. And you will see, I was very surprised when I spent 3.5 hours in the operation theater. There were only 3 people in the whole operation theater doing the same thing. And you see the interface screen on the rear side of the surgeon, and completely taken care of in terms of sterilization. And he just operates all the devices, whether they are medical devices or non-medical devices, he operates, and it is works wonderfully. And it is called a Blu-ray theater, and it's a marketing point for them. The surgeon is a great surgeon. The theater in which he is working is a great theater. So I understand that the patients are so happy to get operated in that room with that surgeon. So this is also coming up in India. So all these are possible in India today. This is the interface. A close look at the interface screen helps you to monitor or to even control the height of the operation table. In fact, you can set the scene. Suppose if Dr. Trimalai Sami is an orthopedic surgeon in a hospital, he wants to do joint replacement. He has some settings for the diathermy, he has a setting for the lights, he has certain settings for the height of the operation table, because he is about 6 footer. He is a 6 footer. So he requires a different height for operating. All that is controlled by this interface screen. So this is an excellent facility. You don't have any wires moving around. Although the pendants did that for us, but I think this was awesome. This was a completely different technology which is going to happen. Of course, how do we do it? And in fact, I went and saw some of the hospitals there in Germany, which we are replicating in the hospital now. There's a German hospital, and you see all the HIS details are through the computer terminal, and the doctor can key in his notes, the nurses can key in their notes. All that is done inside the operation theater. So you have a computer terminal inside, you have the PACS display units there, you have 2 display units embedded onto the screen. That is also controlled through the interface screen. Practically there are no terminals. I asked him, why have you kept these terminals? This is only for an emergency as per the German standards. And even the doors, of course, these doors are available now. Our good manufacturers are there in India. We are using those doors. These doors are completely automated, and everything is remote in this place. And what I was surprised, I'm sure in India also, I find a lot of our contractors and engineers are doing this. The way they lay their IT networking cables, the AC cables, the pneumatic lines, I was very impressed, and I wish our Indians follow this. And what do you talk about an ICU integrated ICU? There are different ICUs in the hospital. You talk about the coronary care ICU, talk about the surgical ICU, neonatal ICU. There may be about 10 ICUs. Each of the ICUs may have about 7, 10, 12, 15. Maybe in our hospital we have 100 ICU beds. These are all the different ICU beds, and you must understand there are a host of equipments that go into the intensive care. It may be ventilators, monitors, infusion pumps, syringe pumps, name it, alphabet. All these are now possible to be integrated through a charting solution. This is another view of another intensive care, and this is the new intensive care. You find and all these equipments can now be integrated. Of course, central monitoring is there already in all these hospitals, but we are now reorganizing the theater to have an integrated ICU. This was built about 20 years ago. We are putting down that, and even the nursing station is being changed. And another nice thing is, even in the ICU and in the operation theater, the way we move the transport the patient is completely ICT enabled. So you can program the dose on this bed. Maybe it will give you an alarm. It is a motorized cart. It just runs as though it is a battery car in the hospital. And see, this is another technology that has come in. You find pendants fully ICT enabled. You can do anything. Some mechanical pendants are there, dry and wet. All those are there. It's so beautifully done up. These are some of the pendants that are fully ICT enabled here. You find all these are completely network. You were wondering why I was showing you that the auditorium. You find in this kind of a facility, you can integrate the auditorium into our this thing as we do. But although we have the connectivity, we get somebody to do it, and we spend a lot of money on it. And today, some of the ultrasound pictures you get in that is as good as what you see in the ultrasound room. That is the nicest thing about this integration, and you see so many people are able to do it. This is the charting solution I was talking about. These are all the equipment that can be integrated. Once you integrate it, all the data flow directly into the HIS server, whether it is ventilator or whether it is monitor or infusion pumps, all that flow into it. This is how these devices are connected. Then these charts are all automatically made. Now we are depending on the nurses to make those charts. And once these charts are made, it's easy for the nurses and good for the doctors. And even the food intake calories are all calculated. Flow charts are monitored to this. And we also send critical data like lab results and all that through the mobile system to the doctors. And this is the screen I told you for just for transferring the patients. Maybe he wants a cot from the emergency. This is the kind of requisition they make. And this is the this is how we follow the patients. They have gone for this is the chart. All these things are captured. All these things are captured in the dashboard, as they are saying. This is a real time, so the doctors can know whether it is about the surgery, minor surgery, or major surgery, or the time that is taken. It is also possible to have the dashboards into it. Of course, the last is I thought something about the non-medical aspects of the integrating the ICUs. This is what I saw in Mass General, and I thought we should replicate it. There is a control room, and what we have done is we have connected all the ICUs, all the operation theaters to the central monitoring room like that, like this, and we can monitor the temperature before the doctor complains about maybe high humidity or maybe high temperature. We will be able to monitor it. And you see, this is the BMS solution here. This is the real one inside the hospital, and we can change the ICU temperature in the AHU and things like that. Of course, the last is we use now speech recognition in the operation theater for dictating notes so that we can reduce the time for the nurses and also for the doctors. Thank you very much for this opportunity, and looking forward for some questions and answers. Thank you.
Thank you very much. I request the anchor to announce the next speaker. May I request the speakers to keep to time, as the valedictory function is coming after this and the governor is going to be here. Thank you very much.
Thank you, sir. And now may I please request Dr. V. Balasubramaniam, Professor, Department of Anatomy, St. John's Hospital, Bangalore, to deliver his speech.
respected dignitaries on the dais, and my dear friends. Firstly, it's very nice to be with you all, and my humble thanks to Professor Ganapati and the Apollo team. Let me place myself before I address you for the next 10 to 12 minutes. I am a ground level practitioner of e-learning. I will share with you how I not only design software packages for teaching various types of medical audiences, which may vary from MBBS students to nurses to general practitioners, you name it, even patients I put under the heading e-learning. I shall show you a battery of methods I use per se in my department, and I shall wind up with what could be the future trends. This is the objective of my discussion. Let us say, for a moment, this is turned into a lecture class. For those who are not doctors in the audience, let's say this is a class on a topic called embryology, where I'm going to talk about the growth of the baby in the womb of the mother, which neither the student nor the teacher has actually seen. So it is virtually abstract. I'm going to show you how I harness information technology, and I'm going to use animations and teach. So have a look at this. Take a look at this. You will get an idea how, in addition to routine teaching with blackboard, with slides, I make sure I add on value to my lecture using short video clips, or rather animation clips like this. Each of these clips are custom designed to suit my lecture. Note as I teach, each animation can be repurposed. Let us say somebody else wants to teach the same thing in a different context. The same animation can be repurposed, the labels can be altered, so that using a core set of animations, I can cater to a varied group of audiences. Now I am going to depict the same animation in a different perspective. Let us say a obstetrician would like to use this same animation. You will notice how the same animation is going to be reutilized. It is virtually a replica of what I showed you earlier. The context is different. You see, now this is the fallopian tube, and you can see the growth of the embryo as it passes across the fallopian tube. Now this concept is known as digital learning objects. Before actually doing these animations, a lot of research goes into how many core templates need to be made, subsequent to which we decide how many derivative animations need to be created. So if you do not plan in advance, certainly the whole program will be a waste of time. Likewise, there are times when we use another strategy where we try to dramatize certain events so that the take-home message to the student is better. In the sense, what happens is, more often than not, when I address a student audience, literature is available which says on many occasions, not even 50% of what I want to teach or what I want to convey is understood by the audience in the perspective in which I intend to convey. Probably IT is one of the real tool or a strategy by which I can improve this gap between what I teach and what I learn, what they learn. Of course, I also learn, but what they learn. One of the techniques we use is this dramatization using this type of animations. This is something to do with fertilization. Doctors here will recognize it, but for the non-doctors, now I have a battery of animations to show, but I'm not going to show many animations, but I'm going to switch over to other types of animations. There are times when simple 2D animations may not probably be adequate to convey the scenario to my medical students in totality. It is in such situations I may have to go in for a more expensive yet a more powerful technology, namely the use of 3D. I will give you an example, but before actually showing you the example, I will give you a small prelude. I'm using this. I did this for a pharma company earlier. I'm now using it for teaching my students. In pharmacology, we try to teach our students that there is a distinct difference between a tablet that is destroyed in the stomach, the acidity of the stomach, and an enteric coated tablet. The difference between the two is depicted beautifully in this particular animation. You will also see for the first time that in the intestines there is something live. The beauty of the micro structure of the intestines called the villus. You will see how active it is. You will see this animation from the point the tablet is put into the mouth of the patient till the time it is actually delivered into his bloodstream. Have a look at this. I'm sure you will appreciate that there is a higher value in using such animations in routine teaching. The first part is a tablet that does not have an enteric coating. It has come down into the stomach. The acidity of the stomach is destroying the tablet. Now, the same thing is enteric coated. You will see the difference now. See, it has crossed the pylorus, and now you can see the beauty of the intestine. You see, can you see there? That's the life in the intestines. The local enzymes there is going to not destroy, break the thing into smaller units, molecular units. Now the camera will zoom into 1 microvillus, and you will see the drug being actually taken into the bloodstream. So this is a type of an animation which gives a higher value in my delivery of knowledge. I'll give you another context where I allow the students to use a certain scenario and try to experiment on their own, and by a series of trials and errors, learning takes place. In fact, this is the example where problem-based learning is being addressed. In my opinion, there is a huge gap between what is actually learnt as knowledge and what needs to be actually applied. Now, this example will give you a brief introduction to how we could use this. This is the domain of medical video games. You see, this is a...
We are short of time.
Yes, I'll finish with this. 2 minutes. This is a program available freely on the net. Here, what you can do is, the student can play with this program and he can paralyze a muscle of his choice, and he can immediately see the result of the paralysis. You can see that one side lid is closed. Similarly, he can even manually open it and examine the eye. So what I have done is, in the last few minutes, I have tried to highlight at least 1 or 2 strategies which I have found extremely useful while I address my students and try to convey information. I have also published papers indicating where I have quantitatively measured the outcomes, and I have found it in many instances that IT can be used very successfully in improving medical education. It can be for any audience under the heading medical education. Thank you. If there are any questions, I will be happy to address at the end. Thank you.
Thank you very much. That was a very nice presentation. I request the next speakers to limit their talk to 9 minutes, as we are running very short of time. And as I have already announced, then the next schedule, the valedictory function, the governor will be coming here. Thank you.
Ladies and gentlemen, may I please invite our next speaker, Dr. Neeraj Raj, Managing Director, MedRC Hyderabad, to deliver his speech.
Good afternoon, everyone. I'll try to go as fast as I can, so please pardon the speed at which probably I'll be taking you through. I'm going to demonstrate predominantly a learning management system that integrates the kind of content that the previous speaker, Dr. Balu, has actually dealt with. Of course, this was developed with the intent that there are challenges in healthcare education that we all know. The need to train more doctors with shortage of faculty, uneven distribution of colleges, and non-integrated curriculum. So we looked at how can an e-learning framework that has structured curricular content with uniform access, created with blended learning in mind, as a collaborative tool can lead to capacity building. If you look at the kind of content that was just demonstrated, the kind of content we have built is basically coming from the prescribed curriculum that, leads to a whopping 6,000 modules, each module being 28 minutes with about 50 slides, photographs, illustrations, animation, question banks. And if you look at who can develop such things, there are people like the academic people, say Dr. Balasubramaniam at St. John's, with whom we collaborated, and another 750 teachers of excellence across the country, teamed them up with instruction designers, video teams, graphic illustrators, 2D animators, 3D animators, programmers, and people who could develop the question banks, leading to a huge e-content repository of granular e-learning objects, which are continuously captured and continuously delivered over networks. And what I'm going to show to you is the demo of the same, which has the learning management system, a system where every student is registered on the day he joins MBBS or his whichever course he's taking. All the faculty are registered. Faculty have privileges. Students can be divided into batches. Faculty can give them lessons to do week on week. They can be integrating their lessons well between the pre, para, and clinical subjects across lesson plans, which are subject-wise, chapter-wise, topic-wise, with such illustrations, animations, search tools. And teachers can use this to teach in class using interactive whiteboards, touchscreen-based podiums. And students can use it as self-paced learning, where they can, view, review several times and structure it to their own needs. So when you look at the learning management system itself, and where you need to go online and then log in, basically to get access to whatever you are allowed to see, it populates basically a dashboard, and then a student has access to so many things. And they get tips, basically, they get notices from the university, they get all the things that they need for their educational purposes, which is, for example, if it is a learner, and a learner is from the undergraduate medical stream, he will get his foundation courses, he will get his preclinical, paraclinical, clinical courses. In preclinical, for example, I go to anatomy. I'll just show how perhaps, say, Dr. Balu's lessons would integrate into the learning management system. Say, we go to the head and neck, we go to the osteology, we go to the skull bone, we go to the interiors of the skull, we go to the interiors of the cranial cavity. I would like to take a class from, say, Dr. Balasubramaniam. Then if I say I want to go to a particular point, I want to jump to the, say, the pittus part of the temporal bone. Well, in such a case, the teacher comes up and he starts delivering the lesson to me. So what happens is,
forms an important posterior boundary of the middle cranial fossa.
Now the teacher is there, his teaching material is there, students can watch it this way, students can watch it this way. Now while students are listening to the teacher, students can be adding their notes, saving their notes, sharing their notes with other students. They can be adding bookmarks. This is important for a case that I saw in the ward. This is important from my PG entrance point of view. Now 5 years later, probably all his PG entrance bookmarks he would put together, and then he would have a rapid course that will help him assess himself. He can take multiple choice questions, short questions. He can communicate asking questions through email, sending feedback. He can do search across Google, PubMed, Wiki on this particular topic. He can go to related lectures in other areas. Or rather than having to go in this format, I can go forward. If I have understood, if I have not understood, I can repeat a segment several times. I can say, sir, teach me middle cranial fossa, and it will jump to the topic on that. Or I could have directly searched. I could have said, I want pyramidal track. And then I get lessons from the pyramidal track. I can go on to the lesson. The teacher will come and he'll teach me very clean pedagogically. Basically, it starts with an objectives of the lesson. By the end of the lesson, it assesses you whether you have met those objectives or not. In between, it will take you through all that e-content. It will take you through the animated graphics. Now, all these graphics can be used by teachers to teach in their class, or in a self-learning mode where you have walkthroughs of various portions of the human anatomy, physiology, pathology. Also, it would lend itself to several other formats, like, for example, if I'm teaching how to auscultate clinically. Basically, these are the auscultatory points from the front, from the back, from the sides. From the front, what are the bony markings lying underneath? What are the lung markings? Now, as a teacher, I can pause this. I can start writing over it with an e-pen on a touch screen and show it to the rest of the class. But then, if I were to say, in this case, put up my steth here and listen to sounds in a normal case as compared to a case of, say, severe asthma. I would be able to very objectively, listen to all of these. Same thing in the search mode, in the learner mode, if I'm in searching and I say I want...
1 minute left, please.
Yes, sir. Suppose I search on diabetes, I would be able to get lessons from across my curriculum. So if I say I want to revise for my PG entrance, I have these 6 lessons. I say I have the undergraduate curriculum. In undergraduate curriculum, I would say I would want pathology, so I get pathology lessons. If not, if I want pharmac, I'll get my pharmac lessons. So it also helps in integration across all the areas. Finally, I'd want to end with the tool for assessment, which is again very important because one would be able to go and take assessments across 120,000 questions, about 1,20,000 questions that take you into each part. It's objective type assessments, and the dashboard basically gives you links into looking at performances across various, within the group in the college, within the batch, within college to college comparison, and also comparison across, say, the universities. So with this, I would say that what binds all of this together is this. It is the ecosystem of the learning management system that has the tracking services between when a student joins college till the time he leaves, and even beyond for his continuing medical education. And such an ecosystem populated with such rich e-content that can be used in classroom by the teachers, standardizing teaching across various institutions as a self-directed learning by students across the entire healthcare spectrum would go a long way in creating scalable manpower. Thank you so much.
Thank you very much. It was a very nice presentation.
Ladies and gentlemen, put your hands together to welcome our next speaker, Mr. Sid Ahuja, Vice President, JV Alcatel Lucent Ventures, Bell Labs Innovations, New Jersey.
Thank you. I'm Sudhir Ahuja. I'm at Bell Labs. I'm a computer scientist by profession. Bell Labs is a R&D place for Alcatel-Lucent. I've been a research vice president there in charge of multimedia research and currently I'm vice president of joint ventures. I'm leading a joint venture in telemedicine. I happened to meet Dr. Ganapathy. I want to thank him for inviting me here. And it's a pleasure to speak to all of you. I'm going to give a technology talk slightly different than the earlier talks. They were more about education. This conference is about transforming healthcare with IT. It turns out that even IT itself is evolving. It's funny that healthcare has discovered IT. IT has been around for about 15 years, and actually, sad to say, healthcare is about 10 years behind what other people have already done with IT. And as many of the speakers have said earlier on, there's been a lot of incentive to use the business tools and all the tools that other people have sort of known in the normal IT business to be used in healthcare. And indeed, that's a very good idea. That will happen, and I think you can see from a lot of the talks today as well as yesterday, a lot of the IT is being incorporated. However, in healthcare, there's actually an opportunity to move beyond that. And that's one of the things I'm going to discover describe to you, and what you will discover essentially, is the ability to do more than what standard IT provides, and it's the ability comes from sensor networking. Let me just, can I just get to the next? So a little bit of background on networking itself. My background is computer science and computer networking. I know some of this may be very obvious to you, but I want to get you through a simple concept of how sensor networking comes around and is useful. So we're used to 100 years of telephony. It was designed to be a voice-to-voice network. It was designed to be a person-to-person network, really. And that's what it accomplishes. What's funny is that over 100 years, it hasn't changed very much. It has changed in scale, and it has changed in mobility in terms of where you can reach it. But today, you and I speak exactly the same way we did 100 years back. We dial a number, we dial a person, and it's a point-to-point conversation. It's just the scale is that billions of people can talk today. The amount of bandwidth needed is not very much. In fact, if everybody in the world picked up the phone and talked at the same time, it's about 12 terabits of bandwidth. It can be captured in one fiber. So I think we have solved the problem of people talking. We have not solved the problem of people talking unnecessarily, but we have at least solved the problem of talking with each other across distance. The data networks, when they came around, one of the big change there was that not only people needed to talk to each other, but computers, which were a source of information, needed to talk. The inherently major difference there is that it's a client-server model. It's not a point-to-point model. It inherently is a multi-point model. So you have some information in a server, and many people want to get the information. That's exactly what web is. That's what your chat rooms are. That's what Facebook is, things like that. It inherently allows you to create a group discussion, because the idea is a server creates information, many people can watch it or share with it. I've shown it unidirectional, there is bidirectional information, but it's dominantly from the servers into clients. And that's what we are taking advantage of today. Most of IT is like that, whether it's on the web or whether it's your servers in your LANs, whether your IT servers in your inventory, whether it's EHR, things like that. Those are all servers that many clients essentially are able to access at the same time. The big difference again here is that it is a packet data. It's not a continuous connection like the voice connection is. And therefore, there are advantages in terms of number of transactions we can support here. And also the number of devices is very large. So it has a much bigger scale than the voice network was. The number of endpoints are much larger, orders of magnitude higher, and the amount of bandwidth you need in this transaction is very high. Also, when you add video like YouTube and all that, it's already gone way beyond what voice was. However, the next generation network, so I'm going to go to sensor networking. So in the last two pictures, you already saw that people can talk to each other and people can talk to computers, which are like people. They're intelligent beings. They can communicate with some form of information with you. How do I make this desktop talk to each other? How do I make your chairs talk? How do I make your laptops talk? Other inanimate devices. You already heard Dr. Ganapathy mention so-called Internet of Things. But the idea is to make every object in the room, in the hallway, in the roadways, in your pipelines, how do you make them talk? You make them talk by enabling them to have some electronic device to convert information, depending on what the information is. And second part is have communication. So we're showing you sensors. There are sensors that are like pressure sensors. There are sensors that are like gas sensors in your refrigerators, in your cars, in your RFIDs. There are sensors all over the place that are beginning to happen. The scale of this is actually way beyond even data networks. And we fully sort of can predict now that in the next 10 years, just like data networks took over from voice networks and completely dominate, today everything is internet everything, you will see that in about 5 to 10 years, sensor networks will be everywhere. Now, what's so different about sensor data from today's data? Okay. What is the big difference here is, one, the direction has changed. The data is coming from the periphery into the network. You notice you're sensing stuff around the edges, on the tables, on the roadways, and bringing them back into some place where you can do some analysis. This is exactly what you do when you do patient data sensing, remote patient monitoring, things like that. I'm going to show you instances of that. In fact, the best example of, and the fact that the data is coming in is very different, because each data that's coming in, you can't simply merge it. You have to have a knowledge of what to do with the data. It's not like multicasting, the client-server situation in the data networks, where you took the same data and made n copies and gave it out. I can't take your data and my data and fuse it together to make sense to wherever it's going, like your bank data or my bank data, your temperature and my temperature can't be fused that way. It's very personalized, and therefore people that have to respond to this have a huge problem of influx of billions of bytes of data that's going to come in, and you have to process it. We call it the sensory overload. So a great example of that really is the human system. We're a giant sensory network. We have the peripheral nervous system, we have the central nervous system, but all of this ends up in billions of cells on your skins, on your eyes. We are entirely a sensory creature. Unless you're sitting and meditating, you're really interacting with the world with all these senses, and you're feeding back. Now, the question is, when you have all this sensory information, take your skin, for example, you have a billion cells that are feeding back. Why are they not interrupting your brain all the time? They're alive, they're being sensed, but it is not really taxing you. And the reason is there is a model for that data that's being captured and being filtered and being fused all the way at the edges in the subbrain. I'm going to come back to that. But the idea of being able to use these sensor networks to do some good function requires a very sophisticated model, some model of what you want to do with the data. And that's the critical sort of insight you need to be able to use sensory data. This is very important for health, because health is all about sensing our condition. If you think what a thermometer does, what a glucometer does, what a weight scale does, it's just sensing parameters about you. And if you make them communication enabled, all these sensors will send information about you all the time. If 24/7 I'm generating data about myself, I have to be able to have a model what to do with that data and be able to process it. So I'm going to come back to that. There are new sensors that are, so first is to have sensors, data collection. If you can collect it, you can manage it. You heard it all the time today. So the question is to have very rich set of sensors, whether it's a digital stethoscope, or we, for example, have nano sensors that you can fit into a phone, and just from the radio signals that the phone generates, through Doppler effect, we can tell what your heart rate is, things like that. But the idea is mostly to have a collection of sensors that are wireless, that are enabled and can communicate status about you, whether it's your temperature, pressure, heart rate, and things like that. If you do collect all the data, it allows you to...
1 minute more.
It allows you to essentially enable things like this remote mission monitoring. You saw some demo of this from Qualcomm person yesterday. But more importantly than this is the idea to be able to deal with the sensory overload. In the brain, the bottom stem is what deals with normal sensory overload. And the reason it can deal with that is it has something called a model. So I'm showing you the same diagram I showed you earlier for remote patient monitoring, but these pink blobs are basically little intelligence models. You create a model for what a heartbeat should be like. What is the normal range? What is the not normal range? And when it exceeds that, that's when you send the data. Because one of the things about sensors is they'll send data 24/7. And you will extremely get overloaded with that data. So all we are saying is you need to develop models of how you collect the data. And these models are something that the doctors will help you generate. So the idea of this is that this, in fact, is very important for healthcare. We can use this model to do much better healthcare, but you need to be able to extract that knowledge from the doctors into units like this. This sort of, I remember earlier Peter Reddy saying about predictive sort of healthcare. This is sort of the model to develop that. Okay, we can go into more detail. We have only 9 minutes. Thank you very much. If you have questions, you can reach me later. Thank you very much.
Thank you very much for a very nice and thought-stimulating presentation. Thank you.
And ladies and gentlemen, our last speaker of this session, please welcome Mr. Sanjeev Zutshi, the Chief Executive Officer, MedVarsity Online Limited.
No, I'm okay. This is on. Good afternoon, everyone. Invariably, I get to speak after lunch, so I hope I have everybody's attention. Sid did bring us back from education into technology. Sid, that was quite an impressive presentation. Let me attempt to bring the room back into education and medical education, because that's the business we are in. I'm here to share with you a brief about what MedVarsity Online is, and also to give you a small dovetail on what the current use of information, communications and technology is in the online space. I know I'm limited to 9 minutes, so let's move on. We have the red, which denotes past in this image that I have, and green moves on to the present. So if you see in India, the scenario is you have lakhs of practicing doctors and nurses who've not had access to medical education in terms of online space or continuous medical education. India remains home to one of the largest student populations today in the world, and information, communications and technology in medical education, I like to say it is the beginning of a marvelous journey. Web 2.0 and 3G tools give businesses like us enough scalability and innovation to continue to add Sir Muir Gray spoke yesterday about the third paradigm in medical education, and I think that paradigm is where the patient is going to decide what the doctors are going to be doing. Let's look at the online ICT space. It is huge. Internet users now are about 100 million in India, and each time I look at the statistics, it is increasing. The online advertising market today in India is about 1,000 crores. YouTube, for example, has about 20 million unique users, and you go on and go forth. 40 million people today in India want to use their mobile handsets to want to log on to the internet. There are, at last counts, about 3,000 startups waiting to enter this space, the online education space, or the online space rather, in the next 3 to 5 years. What are the key challenges that MedVarsity and other organizations would have faced in deploying ICT in medical education? There is a traditional method, which is a chalk and talk and the click and enter, so people resist change. Physicians today are facing patients, and I've been hearing that in the Patient Safety Week as well as in this current conference, that you have the physician facing a customer or a patient who is more internet savvy, who's been Googling and will have to want to ask you every possible question. We also face a challenge that we need to create awareness for adapting new technologies, and that's where the role of ICT comes in. And of course, finally, to motivate medical students, which are our end users, to be able to use ICT for information, learning, and development. We all know the benefits of e-learning. Let me quickly recap it. Flexibility, adaptively. We've seen a lot of cutting-edge content that Dr. Neera showed us, interactive, and it can be teacher-led, it can be student-led, and finally, of course, retention level. Anything that is visual is more easy to retain. And finally, if you've been from Delhi, where I'm reaching tonight, I know what the traffic situation is, so we add that as a point now as a benefit. MedVarsity was born in April 2000, and it was the vision of our chairman, Dr. Pratap Reddy, who was able to see that this is where the space is going, and that vision comes true 11 years ago when you look at the previous slide, when we can actually see what is happening in the online space. We are headquartered in Hyderabad, and we've recently celebrated 10 years. I'm proud to share with you that in this 10-year journey, MedVarsity has trained over 25,000 medical students, professionals, allied medical professionals, and we have an international student base spanning 46 countries apart from India, which is our main market. And the current proprietary LMS that MedVarsity has supports more than 25 courses for doctors, nurses, and allied medical professionals. Dr. Reddy, the great visionary, as we know him to be, 11 years ago was able to come up with a very topical mission statement, which is very relevant today as well, which is to be able to deliver relevant information technology based quality education to the healthcare providers at any distance and to facilitate cutting-edge research in delivery of medical education. And this is what the key challenges that we have when we go to work every day to make sure that MedVarsity is ready for the next generation. Over the 10-year period, we've acquired partners, and over the next several months, MedVarsity is looking at several more strategic alliances, which you would be reading about. We have a very good alliance with the RCGP, Royal College of General Physicians, where we run diploma in emergency medicine and diploma in family medicine. We've been running these courses now for 10 years, which have been well recognized in the industry and well accepted. We also work closely with the Administrative College of India, where we run courses for training CEOs and staffs of TPAs. We've recently signed an MOU with BMJ, and we would be looking at bringing them into India to add further cutting-edge content and courses for the medical fraternity. And finally, MedVarsity is the only person chosen to market the University of Sydney pediatric course here in India. I firmly believe that no amount of technology or no amount of the net or any kind of different technology is going to determine the future of medical education. It will be patience. So I would like to say that there is a paradigm shift. MedVarsity recognizes it, and we are wanting to help the medical practitioner be in that space so that he can face the internet savvy patient. What is the value proposition that MedVarsity brings in? Well, we have our own proprietary learning management service. We have cutting edge content. We have a hybrid model where we give books as well as the learning is done online. We also have experience centers where we conduct touch and field contact programs at the main Apollo hospitals in the metros and otherwise. We have a robust sales and marketing distribution setup. And of course, we've been in this business for 10 years, and we believe that we are at an inflection point now to grow this business. MedVarsity believes that there is a parallel universe out and we need to be part of that community, and therefore MedVarsity is on Blogger, Facebook, LinkedIn, etc., all the social media. What could be the way forward in this space? Well, we've seen throughout the IT conference that there is growing popularity of wireless technologies. People want to be able to learn at their pace, at their time, with flexibility. I think we're going to reach a situation where the internet viewing will be as much as the TV or will actually overtake it. And I firmly believe the next decade will have India as one of the largest internet users in the world. We are the third largest currently. I do believe the handheld devices is the market, and recently in India we've seen at least 8 or 9 handheld manufacturers wanting to come in and sort of launch their products. And finally, I believe the future, it's there, it's knocking on our doors, and we need to be ready. We will have smart homes, smart students, and smart devices. And MedVarsity wants to be ready for that space. So could this be possible? Someday we will have someone like this be a student. In the event it happens, MedVarsity will be there. And we can see this robot is longing on to a MedVarsity course. So we are ready for the future. Thank you so much for your time. A pleasure to address all of you. Thank you so much.
Thank you very much, Sanjay. It was a very nice presentation, and most important, you have saved time. Thank you. Now we will have 10 minutes for interaction.
Ladies and gentlemen, if there are any questions that you would like to ask to any of our panel members, please put up your hand and we shall give you a mic. We only have 10 minutes for the Q&A session. Are there any questions? Alright, since there are no questions, I'd now like to request our chairperson, Dr. S.S. Reddy, to give away the mementos to our panel of speakers.
Just 1 minute,
Could we please have the mementos?
Excuse me, I just want to...
Definitely, sir.
I'm surprised that there are no questions. I think you are all very tired. But I would like to mention a few things before we complete this session. The human brain as a computer has been estimated with the present palm-top computer size that if you have to create a computer like that, it will occupy 2 square kilometers. That is the capacity of the human brain. Most of us who are very intelligent and smart, we are supposed to utilize only 5% of our brain capacity in our total interaction. People like Einstein, who have been extraordinarily intelligent, they were supposed to have used only 8% of their brain computer capacity. With all this, I would like to mention that the most important part of healthcare is patient-doctor relationship. It can never, ever be either short-circuited or in any way interfered with. Otherwise, healthcare will not be able to deliver what it has to. This has been repeatedly emphasized, and all this technology is to improve the doctor's capacity to interact with his patient so that the direct interaction will be more precise and more important, it will be extremely useful. If that is not brought in mind, it would not be possible to any way deliver health care. Many a time, the patient has complained in NHS that when I go to see the doctor, he is not looking at me, he is looking at his laptop. And this has been a frequent complaint from patients, and that must be always remembered. As regards information where there is an explosion now, there is an enormous information, and I jocularly tell my doctors today, earlier the patients came to you to get examined. Now beware, the patient is coming to examine you because he has got lot of information from various sources. And that is because there is a flood of information. If you click headache, there will be 36,000 references in the internet, which you will take at least 4 years to go through. So that this enormous explosion of information has not added any clarity from the point of view of healthcare for an ordinary patient who clicks into it. And we have analyzed that 85 to 90% of material that you underload is not correct. That is another thing which we must very clearly remember, because anybody, everybody, doctor, non-doctor, patient can onload into the internet any information they want. The Google, which is the most important one, has introduced another wall called Google Scholar for medical information, but that they have made it as a paid channel, so that the access to it is limited. What I would request all of you to understand is the attempt at all this is to aggregate this information to make it very precise, so that as far as possible, the people who download this information will not be confused and boggled. Thank you all very much for having patiently heard us at this session. And now I request the anchor to proceed further. Thank you.
Thank you so much, sir. And now, like I said before, ladies and gentlemen, we'll have the presentation of the mementos by our chairperson to the panel of speakers. Could we please have the mementos? Let us all give them a huge round of applause for an excellent session. I'd now like to invite Mr. Maurice Mars, the Professor of Telehealth, Department of Telehealth, to please present the memento to our chairperson. Ladies and gentlemen, welcome him with a round of applause. The memento is being presented to our chairperson, Dr. S.S. Reddy. A very big thank you to all the dignitaries here. Thank you so much, sir.